Hi, today I'm going to be presenting 2022 AIME II Problem number 4. There is a positive real number x not equal to either 1 over 20 or 1 over 2, such that log 22x to the base 20x is equivalent to log 202x to the base 2x. The value log 22x to the base 20x can be written as log m over 10, where m and n are relatively prime positive integers. Find m plus n. So first, we're going to expand the definition of log and write it as, let's say there's a number n such that log 22x, that n equals log 22x to the base 20x. Then by the definition of log, 20x to the n would be equal to 22x. And because log 22x to the base 20x and log 202x to the base 2x have the same value, we can also do the same with the second equation. 2x to the power n equals 202x. Now we can expand these equations and make it 20 to the power n times x to the power n equals 22x. When we do the same with the other side, we get 2 to the n times x to the n is 202x. When we divide the second equation by the first equation, we get 2 to the n over 20 to the n is 101 over 11, because the x cancels out, the x to the n cancels out, and 2 over 2 over 22 becomes 101 over 11. And when we simplify this becomes 1 over 10 to the n, which is 101 over 11. This is because we can take 2 over 20 out and do to the whole power of n. That becomes 1 over 10 to the power n, but 1 to the power n is just 1, so it's 1 over 10 to the power n. When we take the reciprocal, we get 10 to the n is 11 over 101. So when we take the logarithm of both sides, we get n is log of 11 over 101. And n is what we had to solve for because it says the value log 22x to the base 20x, and that value is equivalent to n. So n equals log 11 over 101. So n can be written as log m over n, and 11 and 101 are m and n. So we have to find m plus n. And 101 plus 11 is 113.